In this video, we are going to see the step 5, that is compaction of concrete. What is compaction? Expelling the entrapped air from the concrete. So when we are mixing the concrete, when we are transporting the concrete, and when we are placing the concrete, the air from the atmosphere is going to entrapped in the concrete. Okay, so what happens is that air is not good for the concrete because that leads to the porosity and decreases the strength of the concrete and durability of the concrete. So you have to remove whatever the entrapped air is present in that. So that process of removing this entrapped air from the concrete is what we call it as compaction. So we use some equipment in order to compact that concrete. More importantly, stiff concrete or workable concrete, low workable concrete have higher percentage of entrapped air. So the water content is less. In concrete mix in which the low water by cement ratio is adopted. And when the concrete is less workable, there is a high chances of entrapped air in the concrete. Higher percentage of air is going to entrap in the concrete. Of course, if it is a flowing concrete or if it is a high workable concrete, there is a less percentage of air that is going to entrap inside the concrete. It is important for us to understand that full compaction of concrete is necessary to achieve maximum density and maximum strength. So, unless you do a full compaction, unless you remove all the entrapped air, you cannot get a maximum density concrete. So, you cannot fully achieve the strength of the concrete. So, what you need to do is you have to get a full compaction and a maximum density concrete. But remember, the workability of the concrete influences the compaction that you can achieve. If a concrete is less workable, compaction becomes hard, difficult. When the workability of the concrete is high, then the removal of air is very much easy. You need to decide while designing the concrete what is the percentage of compaction you need to achieve. If you want high level of compaction, then you need to decide what should be the workability of the concrete. What is the mechanism that I need to use to compact that concrete to achieve that level of compaction. So these are the two factors that influences the compaction. We are going to see here the various methods of compaction of concrete. So there are four methods in which you can compact the concrete. This hand compaction is the one that you may have come across. I'm going to show you some images so that you can clearly understand each and every method in detail. So this is the hand compaction. So you need to use your hand, you need to make use of your hand in order to compact the concrete. And the first one is ramming and second one is damping. And we have rodding, in which we use rod, and sometimes we use wooden rods, or as shown in this figure, rectangular wooden logs to plaster the to compact the surface. So you have to decide what kind of equipment or what kind of a vibration, I mean compaction you wanted to do. So in this ramming, the bottom weight is going to be a bit higher. Therefore, it helps us to get a higher compaction. In case of tamping, this is done for giving a smooth finishing to the surface and also to compact the surface of this concrete when the thickness of this member or this concrete is less. And in this figure, rodding is done by rod This is what we generally see in case of slump contest or in filling this mold for the compressive testing of concrete. So, as you can see, this hand compaction is only adopted when the work is of small magnitude. For larger work, you cannot do this hand compaction. Okay, and this rodding is done continuously over the complete area or effective pack to effectively pack the concrete and drive away any entrapped air. So this is the method of compaction of concrete by vibration. So in this method of vibration, you can achieve a good compaction even at low water by cement ratio. When the water by cement ratio is less, by using hand compaction, you cannot achieve the level of compaction that you need. Even when the water by cement ratio is less or low, by using vibration, you can achieve a high compaction level. And remember that the vibration methods can be used even for a slump of 4 centimeter. And remember, this hand compaction మనం చేయాలి అంటే you need a 12 centimeter of slump minimum. Okay, so let me show you the different ways in which you can compact the concrete by vibration. So here, this is the first one, internal vibrator. So this is also called as needle vibrator or poker vibrator. As you can see this image, there is a vibrating end to this pipe, and this vibrating end is dipped in the concrete, is submerged in the concrete, and therefore this vibrating needle will vibrate the concrete and will remove any entrapped air present in that. This is the first one. We are calling this as internal vibrator because the vibrator end of this equipment is going to be submerged completely inside this vibrator concrete. I hope you can see more clearly in this image the vibrating end being submerged inside this concrete. And the second one is form vibrator. So this is the form vibrator. As you can see, when a beam or column is being constructed, we have a formwork, supporting formwork made of wooden planks, right? On the left side, right side, or bottom, we give support to the concrete, right? To achieve a shape. So what we do is, instead of directly compacting the concrete or vibrating the concrete, we attach these compactors or vibrators to the formwork as shown in this figure. So what happens is these vibrators vibrate this formwork, thereby the concrete. So in this way, you can achieve compaction, that is removal of the entrapped air. And the other one is stable vibrator. This stable vibrator is a machine that is used to vibrate the concrete. So this is the most commonly used machine or the manner of compaction when we are vibrating or compacting concrete cubes for testing purpose. And you can see in this image the fourth one, platform vibrators. So these are something like table vibrators, but these are larger in size. This is the vibrating platform. Here you can see this is a vibrating platform. This is the formwork, and you are placing the concrete in this, and now you are vibrating this whole setup so that the concrete can be achieving its complete compaction. And this is the most commonly method of compaction in pre-stressed elements manufacturing and railway sleepers more particularly. And this is the fifth one, that is surface vibrators. Of course, you people have come across this. This is the most commonly and the old model of this surface vibrator. So there are two handles, and we place this on the concrete, and this is going to vibrate here at bottom, and there is the smooth surface, metal surface here, which comes in contact with concrete, and this is going to vibrate. So two people are going to pull it or push it along the surface of concrete. And this is the vibratory roller. These vibratory rollers are used for a very dry concrete or a lean concrete. Okay, for a very dry concrete. When the water-based cement is very less. So in the pressure jolting, compaction by pressure and jolting, what we do is we are going to apply pressure in order to compact the concrete. So when we apply pressure on the concrete, the the pressure is being applied on the concrete will lead to the removal of the air and trapped air present in the concrete. That leads to the better compaction of the concrete. Of course, this pressure compaction is done for a very low water by cement ratio concretes. And this method has been proved to be very much effective in dealing with this in compaction of this very low water by cement ratio concretes. Okay. And the second one is in the fourth one is spinning. So in spinning, what we are going to do is we are going to rotate the member, such as in the case of concrete pipes, fabrication of concrete pipes. So because of its rotation, because of the centrifugal force that develops on the member, it is going to expel all the air present inside the concrete. We have certain instructions when we are going to use this vibration for the compaction of concrete. The concrete thickness should be not more than 60 mm when you are vibrating. Okay. If you wanted to put concrete of 120 centimeter thick, you can do it in two layers, 60 centimeter and 60 centimeter. First put 60 centimeter of concrete layer, vibrate it, and then you can put the second layer and vibrate it again. So this will help. But if you put 120 centimeter of thickness of concrete layer, vibrating would be less efficient. You cannot achieve a full compaction. So you have to take care of the depth of this concrete layer. Okay. And moreover, the depth of immersion of the vibrator. So this comes when you are using the first kind of vibrator, that is needle vibrator. So the needle vibrator should be inside the concrete in order to fully compact or vibrate the concrete surrounding it. The spacing and number of insertion positions. See, as I told you, when there is a large slab or something like that, or a pavement, concrete pavement, you put needle at regular intervals, which can be this interval can be between 35 to 90 centimeter. I mean, if you put at this position 1, you can go to the position B, which is 35 to 90 centimeter away from the first one. Okay, when the compaction factor is 0.78 to 0.85. This compaction factor is also a measure of workability. Compaction factor test is a test that helps us to determine the workability. The speed of insertion and withdrawal of the vibrating head. So the speed at which you have to put this needle inside the concrete is 3 centimeter per second. This helps in reducing the strain that that operator is undergoing. Okay. And duration of vibration, that is dependent on height of layer, size, and characteristics of vibrator. What kind of vibrating mechanism are you using? What is the workability? What is the thickness of the layer and size of the layer or height of the layer? You have to decide on that. And vibrating concrete at junctions with hardened concrete. See, as I told you, when there is a old concrete and now there is a new concrete that you have placed, and you are vibrating this new concrete, fresh concrete, what you need to do is you have to use a cement grout of 1 is to 1 proportion and one cement and one sand, and you have to prepare a creamy consistent paste, and you have to apply on the wet surface of the old concrete, and then fresh concrete has to be put and it has to be vibrated. And in case of reinforced concrete, vibrating of reinforced concrete, you have to take care of the reinforcement that you have provided. Okay. See, the reinforcement is nothing but the metal rod that you put inside that, right? So this reinforcement is a constraint to our vibration. అది మనం చేసే వైబ్రేషన్ కి కొంతవరకు అడ్డంగా ఉంటుంది. Okay, so the reinforcement may be grouped so that the width of the group of bar do not exceed 25 centimeter and space of 7.5 centimeter exists between the group of bars. సో ఏదైతే మనం బార్స్ పెడుతున్నామో అది గ్రూప్ కింద పెట్టాలి. అండ్ ప్రతి గ్రూప్‌కి కూడా కనీసం 7.5 సెంటీమీటర్స్ స్పేసింగ్ ఉండేటట్టు మనం చూసుకోవాలి. సో థాట్ దిస్ వైబ్రేటర్ దట్ యూ ఆర్ యూజింగ్ నీడిల్ వైబ్రేటర్ దెన్ దట్ కెన్ గో అండ్ వైబ్రేట్ ది కాంక్రీట్. And vibrating near the formwork. Formwork ante ends. See, this is the formwork, and you are going to put the concrete inside it. Okay. So what I'm saying is the suitable distance of the vibrator from the formwork is 10 to 20 centimeter. In the next class, we are going to see the step 6, that is curing of concrete.